All right, guys, two-step equation word problems. Let's keep talking about these word problems. I am going to be putting you some practice on inequalities on the classroom today sometime too, so keep a watch out for that. But let's get this up there so y'all can get this done. We're just going to go through this. Looking at the top up here, it says steps to solving two-step word problems. Read the problem carefully. Underline any key information. Write a let statement. So we're going to be doing all of this. Write an equation, solve the equation, check your answer. Something else that I want to put up here as part of notes for you is that we are going to be looking for, in our problem, a variable term, a constant term, and a total. So we're going to look for a variable term, a constant term, and a total. And then we'll also be looking for an operation symbol. So we'll put our O right there. And then we're going to have an equal sign right there. So our equation is kind of going to be set up. Variable term, operation, constant term, equal sign, total. Okay? So that's going to help you a little bit with putting these equations together. All right? Nick opens a savings account with $500. Each week after he deposits $15. In how many weeks will he have saved $500? Now, one thing that helps a lot with your writing equations is if you can write what I call a per statement. If it doesn't give you one, a per statement. If you can write a per statement, then you will be able to find your variable. Per statements help find the variable term, okay? Per statements. So looking at this, and let me show you what I'm talking about. Each week after he deposits $15. So he deposits $15 per week. $15 per week. So that's going to be our variable, okay? How many weeks? Because it asks how many weeks. Well, here we go. Our weeks is right there, so that's going to be our variable. Well, if that's our variable, here's our constant, and here's our total, okay? So we've got our key information underlined. Write a let statement. What does our variable represent? Once we write our per statement, once we have our per statement, we know that our variable is going to be part of that per statement. So we're going to let W equal the number of weeks. Okay? Let W represent the number of weeks. Now we're going to write our equation. So we're going to need a variable term, an operation, a constant term, an equal sign, and a total. Okay? So here we go. Our variable term, we said, was $15 per week, so that's going to be 15W. $15 per week would be 15W. So that's 15W. Our constant term was 50, and our total was 500. And we're going to put down our operation would be adding, because we're going to take what we've got with what we're saving to get to $500. So now it says solve. So 15W plus 50 equals 500. We're going to subtract 50 from both sides. Excuse me. 15W equals 450. Divide both sides by 15. And W equals, I think it is 30, but I need to get my calculator. So hold on just a minute. Let me grab my calculator. Sorry. 450 divided by 15 is 30. There it is. 450 divided by 15 is 30. Look at me. Reread the question, and does your answer make sense? Does it make sense that it would take him 30 weeks So it will take Nick 30 weeks to have $500 saved. Okay? And just because I'm going to start trying to see who is watching and who's listening to my videos, I want you to do me a favor real quick. Just trace that $sign with something that I can see. Trace that $sign for me, okay? Just trace that. And let's see how many people do that. All right? Draw your little smiley face right here. Draw your little smiley face right there. And that's just going to kind of be some little things that I'm going to be doing to kind of get an idea of who is listening to me on the videos. There'll be lots of other surprises embedded in here too. Alex rents a car for 1 day. He charges it, the charge is $18 plus 12 cents per mile. Look at there, there's our per already done for us. Alex wants to spend exactly $30. How many miles? How many miles per mile? So we know that that's going to be our variable term. This is going to be our variable term. The charge is $18. $18 is a set fee. Anytime you have a set amount, that is your constant term. So let's just make a note of that. Set amounts is your constant term. So this is a constant term because that $18 is set. And then he's going to spend exactly $30. So that's going to be our total. Write a let statement. So we're going to let's let M equal the number of miles. Now let's write an equation. Sorry guys. Okay, we're gonna want a variable term, an operation symbol, a constant term, an equal sign, and our total. Okay? Our variable term, we've already said, is $12 per mile. So that's going to be, 12 cents per mile. So that's going to be 12 cents M. So that's going to be 12 M plus our constant term of $18 is going to equal $30. Now we want to solve our equation. Subtract 18 from both sides. $30 minus 18, my mashed potato brain is tired, is 12. Divide both sides by 12 cents. So we're going to divide 12 by 12 cents, and we get 100. So M equals 100. Reread the question. Does your answer make sense? So Alex can drive 100 miles, period. And that makes sense. He can drive 100 miles at 12 cents per day. That's about right. So Katie wants to buy a bicycle that costs $129. We know that's going to be our total, don't we? This is 12 more than 3 times what she saved last month. How much did she save last month? 24 more. 24 more than 3 times what she saved last month. 24 more than 3 times what she saved last month. How much did she save last month? Well, first we've got to underline our key information. And then we also want to underline the question and circle whatever's important in the question. So month, we want to know the months. So what we have right here, so we're still gonna be looking for that variable term, operation, constant term, and total. But I also want to take a little bit more information out of this problem. So we have this amount is 24 more than 3 times what she saved last month. How much did she save last month? So 3 times what she saved last month is going to be our variable term. 24 is going to be our constant term, okay? 3 times what she saved last month is going to be 3M. 3 times last month, okay? The constant term is 24. So our variable term is 3M. 3 times what she saved last month plus $24 is going to be equal to 129. So let's look at that again. This amount, it says this amount is this. It is 24 more than 3 times what she saved last month. So all of this is equal to $129 because that's what it told us up there. So now we can solve by subtracting 24 from both sides. I'm going to come, sorry, but I'm going to erase that and come over here and solve my problem. I'm going to rewrite the equation and solve it over here so that you have the equation out there by itself to look at, okay? Make sure you can see all that. We're going to subtract 24 from both sides. 3M is equal to 105, and I'm going to just check my math right there just to be sure. Yep. And then we're going to divide both sides by 3. And we get 35. So M is equal to 35, and $35 is what she saved last month. Katie saved $35 last month. Okay, very good. Draw your little heart right there. Perfect. Now, let's do some more. Let's keep moving. Now, right here, I want you to take some time and I want you to pause the video, try one, see how you do, come back to the video. Pause the video, try one. I want you to try these and see how you do on these, okay? So I'm going to do number 1. So you've paused the video, you've worked to number 1, now you're coming back to me for me to go over it with you. So here we go. BL rents a car for 1 day. The charge is $20 plus 12 cents per mile. There's our per statement. So we know that 0.12 M is going to be our variable term. This is going to be our constant term. He wants to spend exactly $80, which is going to be our total. How many miles can he drive? So we want a variable term, an operation, a constant term, and a total. Our variable term is going to be 0.12 plus our constant term, which is 20. And we want that to equal exactly $80. So we're going to subtract 20 from both sides. That should be 12M. 0.12 M, sorry. Divide both sides by 0.12. And M is going to equal to something. 500, sorry. Yeah, 5 times 12. 500. So he can drive 500 miles. All right. When subtracted from 3 times the number, the result is 24. When 12 is subtracted from 3 times the number, when 12 is subtracted from 3 times the number. So this is our variable term. Here's our constant term. Here's our total. So 3 times it. So we want our variable term, an operation, constant term, and a total. 12 is subtracted from. So our constant term 12 is going to go there, and it's going to be subtracted from 3 times a number, and we're going to get 24. So I'm going to come over here and solve it. Add 12 to both sides. 3x equals 36. Divide both sides by 3, and x equals 12. So that's the number. All right, Jill made 20 muffins. She put them in 3 boxes and has 2 muffins left. How many are in each box if they all contain the same amount of muffins? So 20 muffins is going to be our total. She put them in 3 boxes. So we've got, all right, so let's write our per statement. 3 per box. 3 muffins per box, and has 2 muffins left over. So those 2 are going to be what's left. So how many are in each box? How many are in each box? So here we go. Our variable term, we got to have a variable term, an operation, a constant term equal to a total. Our variable term, 3 per box, would be 3b. That's what we're going to call that. 2 is going to be our constant term. This is our constant term, our variable term. So our variable term is 3b, because 3 per box plus the 2 she has left over is going to equal the grand total of 20 muffins. We subtract 2 from both sides. 3b equals 18. Divide both sides by 3. And b is going to equal 6. So there are 6 muffins per box. Okay? If you multiply a number by 3, then subtract 5, you will get 40. So if we multiply a number by 3, multiply a number, it's going to be our variable, call that n, by 3, and then subtract 5, you will get 40. So 5, so this right here, this is our variable term. Here's our constant term. Here's our total. We've got a variable term, an operation, a constant term, and a total. Is that orange dark enough? I think so. Okay. Variable term is going to be 3n, multiply a number by 3, and then subtract 5, we get 40. So let's add 5, oops, that's our equation. Now let's come over here and solve it. We add 5 to both sides. 3n equals 45. N equals 15. I'm just going to double check that because 45 divided by 15 is 3. I knew that. All right, so the number is n. The number is 15. That orange just does not seem like it's dark enough for me. I don't know why, but I'm going to change over to a different color. Joe went to the hobby shop and bought 2 model sports cars at $8.95 each and some paints. If he spent a total of $23.65, so there's our total. There's our total. He went to the hobby shop. 2 model sports cars at $8.95 each and some paint. So what was the cost of the paint? So, our variable term, operation, constant term, total. Some paint we know is going to be our P. That's going to be our variable term. We want to know the paint. 2 model sports cars at $8.95 each. So that's going to be 2 times $8.95. So we're going to have to do that in a minute. And then together it cost $23.65. So some paint time plus this equals $23.65. And if we go ahead and multiply that 2 times $8.95, 2 times $8.95, we get $17.90. So our equation is going to be P plus $17.90 equals $23.65. So if we come over here and solve that, let's come over here and do it. P plus $17.90 equals $23.65. We're going to subtract $17.90 from both sides. And P is going to equal $23.65 minus $17.90. $5.75 was the cost of the paint. The paint cost was $5.75. All right. Ryan made a $3,000 down payment on a car. The total cost of the car was $7,500. He made 36 equal monthly payments to pay the car in full. How much did Ryan pay per month? So, how much did he pay per month? 36 equal monthly payments. Ryan made all right. 3,000 down is going to be our constant term. The total cost was $7,500. That's our total. Oops, sorry, that's supposed to be variable term. I may be fixing to do this wrong. Operation constant term equals our total. Okay. All right, guys, I'm not going to lie to you. My brain has frozen up on this one. So I'm going to think through. I'm going to put me a sticky note right here. We're going to just kind of think through this together for a minute because I don't really want to stop the video. So I'm going to show you how I do this. This is me when my brain just won't function and I can't get my head around. I don't know the answer to every problem. I don't even have a key. I don't even know where the key is. So I have to now think through this. And all right, I know that here's where I'm struggling a little bit. That variable term, I'm thinking plus the $3,000 down payment is going to equal $7,500. So I know that, yep, 36 month equal monthly payments. So we got 36 payments, 36 per, yep, there it is. There it is. Here's what I know. And I talked to Miss Walker about that today because Miss Walker was telling me, she said, I know how to solve this, but I don't know how to write the equation. So here's what I showed her. you can look at this problem and know that, okay, if I take 7,500 and subtract 3,000, $7,500 minus $3,000 minus the 3,000 that he paid, okay, is $4,500. I take that $4,500 and I'm dividing it into 36 monthly payments of $125. I know that he's going to pay $125 per month. That's the math right there. So I subtracted 3,000 and then I'm going to divide that answer by 36. That's the math that we got to do to get the answer. But how do I take that and turn it into an equation? Well, it all goes back to something really important that we've talked about all year in solving equations, and it's called this. Inverse operations. So watch how I take what I know. I just took my problem, pretend that's not there. All right, so I'm going to talk you back through this one more time because this is important. I had $3,000 down payment, $7,500 total. This was my total. And 36 equal payments. All right? So I paid $7,500. I put $3,000 down. So if I take my $7,500, take away the $3,000 that I put down, I'm left with $4,500. Take that $4,500, divide it by 36, and I get 125. That's the math. But I need an equation. I don't need the math. I don't need an answer. I need an equation. So what do? I'm going to go back and do the inverse of all this. We're going to inverse all of this. So if I'm going to need to subtract, the inverse of that is adding. So I know I'm going to be adding in my equation. I'm going to be adding. I subtracted my constant term. So my constant term in my equation is going to be added. If I divided right here to get this, in my equation, I'm going to be multiplying. So this is the math that I need to do to get that answer. This is the math that I need to do to get that answer. Well, there's your equation. Now watch us solve it. To solve this, I subtract 3,000 from both sides. 36M equals 4,500. Look at there. Look right there. There's step one. Now I need to divide both sides by 36. And M equals 125. Look at there. That equation allowed me to do that math. And that's kind of how you can work in reverse to get yourself back to an equation if your brain just freezes up. Work the problem, work it, get an answer, and then work backwards, and then inverse everything in the problem to get your equation. So here's what we had: 36M plus 3,000 equals 7,500. So now to solve that, we're going to subtract 3,000 from both sides. 36M equals 4,500. Divide both sides by 36. And M equals 125. So he's going to pay $125 per month for 36 months. Kendra is buying bottled water for a class trip. She has 16 bottles left over from the last trip. She buys bottles by the case to get a good price. Each case holds 24 bottles. How many cases will she have to buy if she wants to have a total of 160? So there's our total. Look at here. Each case holds 24 bottles. So that's 24 per case. There's our per statement. 16 bottles left over. That's our constant term because that 16 bottles left over, that's constant. That's not going to change. So we've got a variable term, an operation, a constant term, and a total. Our variable term is going to be $24 bottles per case. So we're going to do 24, we'll call it B for bottles, plus our constant term of those 16 bottles she had left over. And together we need that to equal 160 bottles. So if I come over here and rewrite it so I can solve it, subtract 16, 24B equals 144 divided by 24. B equals 6. So she needs, Kendra needs 6 cases of water. All right, that's all, folks. So there's that one. That is your, and there's a lot of information in this when it's going through. You may need to watch this and rewatch this and take more notes and rewatch it and take more notes and rewatch it and take more notes. Watching something through one time sometimes is not enough. So you may want to watch it, take more notes, watch it, take more notes. Get this paper and get ready, get started working on this. I'm going to stop this video, get it started uploading and processing, come back and make the next video, and then get them both uploaded and get everything uploaded. So get this one ready. We're coming to this one next.